Hi friends, today we are going to learn how to solve a no display problem in the laptop, especially like fourth generation onward laptops like Broadwell, Haswell, Skylux and all these processors. So how to solve a no display problem? So you can see in this screen the processor, CPU, then the BIOS is connected to the CPU, then the RAM, DDR3L and the SIO and the screen. These are the main component in the laptops. Okay, so once power get to the entire motherboards and what the signal flows we'll see today. So first all the voltage will be generated like 3 volt, then 5 volt, then 1.05, then 1.35 and the last CPU core and graphics core. After CPU core and graphics core, voltage will be generated, then the SIO generate one signal and that signal is called power OK signal or the system power OK signal. This signal generated by the SIO and this signal goes to CPU. Okay, so this is a 3 volt signal coming from the SIO and goes to the CPU. So you have to check this signal at the SIO pin. You have to go to the diagram and you have to locate the exactly pin. The pin name is called the power OK or the system power OK. This is a 3 volt. If the 3 volt is coming at here, that is a power OK signal, that means your all power streams are okay. Every chip got the proper power. So these are 3 volt, like you see in this animation, this 3 volt will generate and given to the CPU. Now the next is, once the CPU get the power, CPU get this power OK signal or the system power OK signal, CPU reset himself. He reset entire the component inside and he generate a next signal that is called the PLT reset. Okay, he generate a PLT reset. This PLT reset signal reset the entire motherboard, like he reset the motherboard, reset the Wi-Fi, reset the network, reset the audio, everything is reset. Okay, so this signal either you can check on SIO, this is also 3 volt signal, and or you can check on the Wi-Fi card also, the 3 volt signal. If this 3 volt coming PLT reset, that means the CPU is okay and CPU generate this signal. So, okay, so this is the next level signal on the no display issues. So the next is the PLT reset is coming, and if this PLT reset not come, that means possible problem could be the CPU. Suppose the SIO generate the system power OK signal, but the PLT reset is not coming, that means possible fault could be the CPU. So you have to replace the CPU, or maybe this crystal is bad or something like that. Okay, so next is, once the PLT reset is generated, the CPU generate the next signal. It's called the DRAM reset. The DRAM reset is generated by the CPU and the signal is going to the DDR3 RAMs, either DDR3 or DDR3L or 4. So this signal basically goes to the pin number 30 on the DDR3 or DDR3L RAM. You will find 1.5 volt at DDR3 and 1.35 on the DDR3L at pin number 30. So here this voltage is coming, that means the processor is generate that signal, and if the signal is not coming, that means possible fault could be processor again. So this signal, this DRAM reset signal generated by the processor, you have to check on DDR3 pin number 30. Okay, like this. So 1.5 for the DDR3 and 1.35 for the DDR3L. Okay, so the next is, once the CPU generate the DRAM reset, the RAM get reset, and now everything is ready to work. The next is, here at the processor you can see there are 2 crystal. One, this crystal 32.7 kilohertz for basically for the RTC circuit, and the another crystal, this is a 25 megahertz crystal, This crystal is basically used for the clock generation. The clock generation section inside the processor, inside the CPU, everything, all the clocks frequencies are generated inside the processor, plus some external devices also require a different clock frequencies that generate by the CPU. So this signal also you can check on the SIO. You can check on the SIO. This clock is generated by the CPU. You can check this clock signal on LPC clock. That clock frequency is 33 megahertz. You have to check here a 33 megahertz. If this 33 megahertz coming, you can check on the oscilloscope only. You can't check on the multimeter. So if the 33 megahertz coming on the LPC clock, then that means the CPU generated the clock and the clock sections working fine. Clock section is okay. The next is, once the clock is generated, the next is the processor started working and he accessed the BIOS. The BIOS is one chip who keep all the command, and CPU access the BIOS and he perform his next task, like it's called the post. It's called a power on self test. There he tests all the devices. So in the BIOS you can see there are 8 pin BIOS. The pin number 1 is called the chip select pin. Pin number 2 is a read, pin number 4 is a ground, pin number 5 is a clock, pin number 6 is a write, and pin number 8 is a supply. There you can find a 3 volt at pin number 8. Okay, so after the clock, CPU access the BIOS like this. He access the BIOS, he read the BIOS, and this signal also you can check either on oscilloscope. You have to connect oscilloscope at pin number 1. You will find a pulses on the oscilloscope. You have to keep oscilloscope on 1 volt and you will find a pulses. If these pulses are coming, that means the CPU is okay and is trying to access the BIOS. Then you can check on pin number 2 that the pulse is going inside the CPU, like that. So okay, so next is, once the CPU access the BIOS, is ready to work and he started doing the post. It's called the power on self test. In the power on self test, he access the bus, and the next signal you have to check for the no display. Okay, if this signal is not coming at pin number 5 is not coming anything, that means the again CPU is a faulty, and at pin number 2 if nothing coming here, that means the BIOS chip is bad. The next you have to check is the frame signal, okay, on the SIO. Here most of the signal you have to check on the SIO only, because the SIO is a component where the most of the signals comes. So SIO is the easiest way to check all the components. So you have to check the frame signal. You have to keep oscilloscope on the 1 volt. You will find some pulses coming on the oscilloscope, and if these pulses are not coming, then the possible fault could be a BIOS. You have to flash the BIOS and check. Okay, you have to flash the BIOS. If you flash the BIOS, still if the pulses are not coming, then the possibly fault could be again in the CPU. So it's like that. Okay, so next is, if the frame signal is coming, then the next is you have to check. The next signal is called the SMBus. SMBus is a two-way communication protocol on the RAM. There is one small chips that is called the SPD, serial presence detect, where when a CPU do the post, it's called the power on self test. At that time CPU access the RAM, and that time RAM tell the CPU that what is the capacity of the RAM and who make it, and all this information RAM given to the CPU. So that information accessed by SMBus. The SMBus you have to use a RAM card tester here, or you can check on pin number 200. You have to connect oscilloscope and you have to check there. You will find some pulses. That this pulses will come only on initial level. Only on initial level. Just start up, that pulses comes. If these pulses are coming, that means the CPU accessing the RAM, like that. So the next is after SMBus is done, the completed its task, then the CPU check the whether display is there. That LCD panel either a 30 pin or a 40 pin. There is a pins called the assembles. This is a two-wire communication where he check the display is there or not. Okay, and if this signal is not responding, then possible fault could be the display. And once they communicate with the CPU and the display, then CPU send the data to the display and the display will occurs. So in this way this signal process work. So next video we'll see a practical how we'll check all the signal on the practically. For the time being, thank you very much.